Welcome to the first lesson on deductive reasoning. And in this lesson, we will learn about if-then statements and converses. As we begin, I'd like to discuss the importance of this lesson. And to discuss the importance, you first need to understand what is an if-then statement. We'll get into more detail a little later, but for now, I will say that if-then statements is simply a statement that says, if something is true, then this other thing must also be true. It is a way to logically think through something. So why is this important to know? Well, many different areas, but one in particular is with debating. If you're going to be debating someone, whether it be a friend, whether it be in politics, whatever the scenario, it is important to know how to use if-then statements. Because you cannot carry on a logical argument unless you have logical if-then statements. Also with computer programming, you use if-then statements all the time with computer programming. If you push this button, then you want this to happen, or something along those lines, where you will see this all the time in programming. And then even just in planning, whether it be a wedding or graduation or whatever, you need to at least think through if-then statements. If it rains, then what do we do? So we see this in planning. Also, just everyday life, it is important to know how to think logically using these if-then statements just to get through a day of life. Like I said, if it rains, what do I do? If there's an accident on the road, which direction will I need to go? There's all sorts of applications to this, and we're just kind of introducing to you the basics. So using if-then statements, here's example 1. We see here, if tomato is a fruit, then ketchup is a fruit smoothie. This is an if-then statement. Now there are a couple other names that we can give to if-then statements. And another name we could give to them is also called conditional statements. Another name would be just simply conditionals. These all mean the same thing. Now let's take a look at these conditional statements and look at the different parts of them. That first part in red, tomato is a fruit, that part with the if word is what we call the hypothesis. The yellow portion, the part with the then, is called the conclusion. So make sure that you can distinguish hypothesis versus conclusion. So here's some practice questions that you can test yourself with. If 2x minus 1 equals 5, then x equals 3. What is your hypothesis? What is your conclusion? If you said 2x minus 1 equals 5 as your hypothesis, you would be correct. And then the x plus 3 would be your conclusion. Here's another example. I can't sleep if I'm not tired. If you said I can't sleep is your hypothesis, you would actually be incorrect. Even though I can't sleep comes first, notice that the part with the if word would be the I'm not tired. If I'm not tired, then I can't sleep. The word then is not written, but is kind of assumed. So because if I'm not tired is the one phrase, that's going to be your hypothesis. It's with the if. So the red part would be the conclusion. The green part would be the hypothesis. Here's another example. 8y equals 40 implies that y equals 5. Now notice you don't see the words if and then in this statement, but the way that this is worded, you can actually input or assume them to be there. So the word implies means that if this part is true, then y must equal 5. So the implies word can be replaced with an if and then a then. So 8y equals 40 would be with the if, so that's your hypothesis, and y equals 5 is with the then, so that would be your conclusion. Another term to know is the word converse. Now when you think Converse, most people think of the shoe. However, In geometry and in logic, converse is when you switch the if and the then statement. So for example, if I were to say, if I live in Michigan, then I live south of Canada. This is your conditional statement. And if you're asked to tell me what is the converse of this statement, all you do is you simply switch the if and the then portion. So instead of saying, if I live in Michigan, you would say, if I live south of Canada. And then instead of saying, then I live south of Canada, you would say, then I live in Michigan. So notice I just simply changed the if and the then portion. Now another term that you need to know is the term counterexample. Counterexample is simply something that proves the if-then statement wrong. So using the same example, if I live south of Canada, then I live in Michigan. A counterexample would be something where the hypothesis is true, but the conclusion is false. So you want a state that is south of Canada that makes that first part true. So let's take Oklahoma, for example. Oklahoma is south of Canada. So if you live in Oklahoma, would you therefore live in Michigan? Well, no. Oklahoma is south of Canada, but it does not mean that you're living in Michigan. So Oklahoma, California, and really any state that is south of Canada that's not Michigan would be a counterexample. So that's how counterexamples work. This is a basic illustration, but the concept is the fact you want to make the hypothesis true, but then the conclusion is false. Let's look at another example of converse, and I'm going to tie this in with another term, another concept that you need to know. Here's another example where it says, if today is Friday, then tomorrow is Saturday. So a converse of this would be simply changing the if and the then portion. So instead of if today is Friday, you would say if tomorrow is Saturday. Instead of saying then tomorrow is Saturday, you would say then today is Friday. So we just switch the if and the then portion. And this leads us to another term that we need to know, and we're going to get back to this, what we just did, in a second. And the next term is the term biconditional. We see in this term the prefix bi. Now hopefully we know that bi means two, like a bicycle would be two wheels. So bi means two, so this literally means a statement where there's two of them. So a combination of two statements where a statement and its converse are both true. So for example, looking back at the previous slide where we had if today is Friday, then tomorrow is Saturday, the converse we already determined to be if tomorrow is Saturday, then today is Friday. Now the biconditional statement would be where both of these are true. We have two statements that are true at the same time, the original statement as well as the converse. So the biconditional statement would be if today is Friday, then tomorrow is Saturday, and if tomorrow is Saturday, then today is Friday. They are two statements put into one, and that is called a biconditional. Now writing a biconditional is going to be tedious because you're combining two statements. So there's actually a quicker way to write this. So the long way is what we just did. The short way would be instead to put the phrase if and only if in between our statements. So we'd say today is Friday, if and only if tomorrow is Saturday. That is the same statement as the long way. And in addition, there's an even shorter way of writing this. Instead of writing the phrase if and only if, we can replace that with this IFF. So IFF means if and only if. So notice that is much quicker to say and to write than the long way. So make sure you go back the other way as well, where if you're told a statement, such as you are hungry, IFF, or if you want to eat, how would you write this back out as two statements? Well, you'd say, if you are hungry, then you want to eat. And the other statement, the converse would be, if you want to eat, then you are hungry. So make sure that you know how to go back and forth between the two statements and converting it back to one statement, or vice versa. And that concludes our first lesson on deductive reasoning, and we will see you next time.